In this video, we're going to look at finding specific antiderivatives. So if we want to know a specific antiderivative, this kind of problem is called an initial value problem, also known as IVT. All right. Let's look at our first example here of something like this. Let's suppose we want to find f of t when lowercase f of t is t plus 1 over t cubed with t greater than 0 and f of 1, capital F of 1, is equal to 6. Okay. And again, what does this mean? Usually the capital F represents some antiderivative of the lowercase f of t function here. All right, so how do we do this? Well, first off, f of t was, I'll just rewrite it here, t plus 1 over t cubed, or in other words, t is equal to, t plus t to the negative third power. Well, what is our antiderivative of that? Well, we need to use our rules from before. So we add 1 to this exponent, so that's t to the first, so it's going to be t to the second now. And then we got to divide by that new exponent. So this is 1 over 2, t to the second. And then we add 1 to the negative 3, it becomes a negative 2. So then we divide by negative 2. So this is now a minus 1 over 2, t to the negative second power. And of course, then to find the general antiderivative, we have to add some constant c. Now, how do we actually finish up this problem? Well, we need to use our initial value here, which is f of 1 equal to 6. So what does that mean? Well, let's just go ahead and plug that in. F of 1 is equal to 6, and this is equal to, let's plug in 1 into our function here. So this is 1/2 times 1 squared minus 1 over 2 times 1 squared plus some constant c. Well, this tells us that 6 is equal to 1/2 minus 1/2 plus c, or in other words, c is equal to 6. So this tells us that then our antiderivative, our specific antiderivative that we want to find, is f of t equal to t squared over 2 minus 1 over 2t squared plus 6. And that is our solution to this initial value problem. All right. Let's go ahead and do something very similar here, but relate it back to the position function, velocity function, and acceleration function. So in example 2 here, we are going to suppose a particle is moving in a straight line with the given data. And our given data, well, first off, I should say, let's find the position function of the particle if and here's our given data, that the acceleration function a of t is equal to 3 cosine of t minus 2 sine of t, given initial values here, and we need actually two initial values here. S of 0 is 0, and v of 0 is 4. We'll see why we need two as we work this problem. So the first thing to do here is notice that, all right, a of t is 3 cosine of t minus 2 sine of t. So what we need to do is we need to find the general antiderivative of the acceleration, which is a velocity function, right? We talked about that in the previous video, but we know that a derivative of a velocity function is acceleration. So the antiderivative of acceleration is velocity. All right, so the derivative of sine is positive cosine. So the antiderivative of cosine is positive sine. So this is 3 sine of t. And then the derivative of cosine is negative sine. So the antiderivative of a negative sine is positive cosine. So this is positive 2 cosine of t here. Plus, of course, some value c. Now, as in derivatives, we can just ignore this constant multiplier out in front, and that's why I did that here, and we just wrote down those constant multipliers out in front. Okay, now how do we find this c value? Well, we use our initial value here, v of 0 is equal to 4. So we go ahead and plug that in. This is 3 sine of 0 plus 2 cosine of 0 plus c. Well, 3 sine of 0 is 0 plus 2 times cosine of 0. Cosine of 0 is 1, so this is 2 times 1 plus c. So what we get here is 4 is equal to 2 plus c. Or in other words, c is equal to 2. So really, v of t is 3 sine of t plus 2 cosine of t plus 2. All right. Well, the derivative of a position function is a velocity function. So if we antiderive this velocity function, we get a position function. So let's go ahead and do that now. So the general antiderivative here, s of t, is, all right, the derivative of cosine is negative sine. So the derivative of negative cosine is positive sine. In other words, the antiderivative of positive sine is negative cosine. And the derivative of sine is cosine, so the antiderivative of cosine is positive sine here. Antiderivative of a constant 2 is 2t, right? The derivative of 2t is just 2. And then, of course, we need to add some constant here, c. And then we need to use our initial value problem. S of 0 is 0. So let's go ahead and do that. S of 0 is 0. So then we go ahead and plug that in. Negative 3 cosine of 0 plus 2 sine of 0 plus 2 times 0 plus c. So this is 0 is equal to cosine of 0 is 1, so this is negative 3. Sine of 0 is 0, so this is 0. 2 times 0 is 0 plus c. So we see that c is positive 3. This tells us our this tells us our specific antiderivative here, our position function that we were searching for that satisfies this data up here, an initial acceleration function, and then our two initial value problems or statements there. Well, this tells us our solution again is negative 3 cosine of t plus 2 sine of t plus 2t plus 3. All right, we just plug in that 3 for c there. All right, and that is where we will end this video.